So for one-step equations with multiplication and division, I'm going to show you what the models look like first because these are a little weird. These are going to look really weird at first because you really haven't had this before. The adding and subtracting strip diagrams you've had for probably 3-4 years. Some teachers spend more time on it than others, but these are a little wonky. I could still write this as an addition problem. X plus X plus X equals 12. But when you see something over and over and over again in an addition sentence, what do you automatically want to do? Multiply, right? So technically, this will get me the right answer, but the way this equation is going to be written is 3x equals 12. Remember, when a number is next to a variable, this means you multiply. This is how your algebra multiplication is going to look for the most part. So, if you see a bunch of boxes squished up next to each other like this with a variable in it, you're going to multiply. 3 times x equals 12. You guys are already knowing that x equals 4. Pretty easy, right? So, you're going to see models this way, and sometimes you're going to see a model this way. So if you see this model, what does that show there? Harper? 3 times 5. 3 times 5 equals x. So I know x has to equal 15 because that's the only thing that makes sense. Does that make sense? So these are the main ones you're going to see when it comes to the models. And again, I don't really see these often after 5th grade, so I don't spend a lot of time on it. But you do have to make sure, sometimes they're going to show you a model and ask you to pick the equation that matches it. And if you don't understand what the model means, you cannot answer that question, no matter how good you are at math. Your multiplication, again, is going to be written really differently. When you have a number and a letter together like this, this is called a coefficient. You will see this word again. You're going to see this word again all through middle school. You'll see it again in high school. They expect you to just know what it is when you come through the door. So a coefficient is a way of writing a multiplication statement. And going back to our inverse operations, I know if I'm multiplying here, the inverse operation of multiplication is division. So what I'm doing to solve for C is dividing both sides by 4. So 4 divided by 4 is 1, right? You're never going to see 1 and a variable next to each other, but it's always there. Kind of like the decimal after your whole number. 2 plus 2 equals 4. They don't write 2 decimal 0 plus 2 decimal 0 equals 4 decimal 0 in kindergarten. That's just too confusing, but it's always there, right? You can add it on if you need it for a problem. But this 1C, we would never put 1. We're just going to solve for C, and C equals 4. Now, a lot of you are thinking, well, this is stupid. I know 4 times 4 is 16. Why do I have to do this? Well, when it's a big problem like this, you're going to have to know what to do. And if you don't understand that I'm using the inverse operation of division, you can't solve this problem. Okay? So you have to know that when you're solving for variables in equations, you have to use the inverse operation, and the opposite of multiply is divide. Divide is multiply. You're doing the opposite. 4 divided by 4 is 1, so I can cancel out the 4's. And I don't even know if this works out perfectly. Did anybody write it out? What is it? 83. Give me a shake if that's what you got. Did anybody do it? I'm going to go with 83 because I trust your math. Thank you. Save you a step. Everybody say thank you. So this is what the multiplication ones look like. Got it? The division ones are trickier. Okay? With the division ones, you're going to see sometimes it's going to be written like this. More often it's going to be written like this. Do not freak out if you see it written like a fraction. This is what division looks like in middle school for almost all your work. It means the exactly the same thing. They're both the same, okay? But on this, if I'm dividing on this side, what am I going to do for the inverse operation? Multiply by 5. So you're always going to do the inverse operation to cancel these out. And 8 times 5 is 40. And you're done. Does this make sense? So you're always doing the inverse operation. And sometimes it's going to be written this way. But if you just ask yourself, if I'm dividing on this side, I'm doing the opposite to get my answer. So this one here, m would equal 50. But your goal is always to get the variable alone and your solution on the other side. Does this make sense? Once you get really good at these, the one-step ones, you're going to get to where you can do them in your head, unless you're using decimals or big numbers. But next year with the negative integers, it gets kind of tricky. Okay,